All right. Welcome, everybody, to the third round of lightning talks at PyData Global 2022. Um, just as a reminder, you guys all have 10 minutes to do your talks. And when you're at the 9-minute mark with a minute left, I will try to create, I will try to play the sound, which will slowly go from soft to louder to louder. All right. And so without further ado, the first talk of the day is by Adit Kapoor, utilizing word embeddings and gradient boosting to identify, analyze, prevent, and predict machine errors in the computer-aided manufacturing industry. Welcome, Kapoor, and I am now adding your slides to the screen.
Right. Yeah. So, welcome everyone uh, to this lightning talk where we talk about the how to utilize word embeddings and gradient boosting to identify, analyze, and predict errors in the machine-aided manufacturing industry. So, first, I will go through some points regarding what are we trying to solve and what's about the industry and what algorithms did we use and what was the real world impact. So this is the dental milling machine. I don't know if how many of you have been to the dental lab before. Whenever you get braces, these machines print out your teeth structure, and DD Shape builds those machines. And these machines have a lot of maintenance to do, and they are basically supplied to dental labs. And on the right side, you could see a distribution of the data that they collect. So these machines are data heavy with lots of data flowing into them at every day whenever the machine is being used. So what are we trying to solve? So for a given machine, and this could be any machine, but for our case, this could be a dental milling machine. We are trying to solve using all the data stored. Can we first thing is prognosis. So basically, I call these three P's. First P is prognosis. Can we identify or analyze the machine errors? Then prevent. Can we prevent it? Can the machine errors be prevented? And predict. Can future errors based on a machine could be predicted? Now, this problem is a very well-known one in the in the car industry. But in our case, for the milling industry, this is one of a kind problem. How can we use data science and AI to perform these three Ps? So these are something about the stats of the computer aided manufacturing industry. And sometimes the question would come up, why complicate things using AI or data science to like in the machine? And these are some points. So basically, if we apply these three P's to get information, then we would have a better customer retention. We have a better support system where instead of calling customer service, the dental lab owner in our case could easily highlight the problem, basically allow the software to find the problem. And third point, uh, is that this technology provides the engineers to better design machines so they can see, okay, using these sensor values we had these many errors, so we can build up a new sensor in the next version. So these can be helpful in these 3 points, this technology. So now let's talk about the data bandwidth that we have. We have a lot of sensor and log data. As I said, if you recall from the slides, we had about 80% as log and sensor data. And what's our outcome? To build future models and explainable models, basically. And this is where gradient boosting comes in the play. And what's the dimensionality? So we have 23 columns, and as you would see that this is a typical case of class imbalance where there are lots of errors. There are no errors, but lots of no error sensor values. So, and one other problem that we faced was the sensor data and log data are separate entities. They are in no way related up to up till this point. Uh, so we had to find some way to consolidate the streaming data. And the last point is there are two variants of the machine. So there's this question of how should we proceed? Should we build two models or different machines, or one model for each version of the machine, or each generation of the machine? And then what's our compute availability? So these three things were to consider when using word embeddings and gradient boosting to identify, predict, and prevent errors. So the first algorithm that I would like to talk about are word embeddings. Now, word embeddings have been heavily used in a lot of different places. But if we talk about log analysis, word embeddings have been used, but it's not that popular. So what do we have? We have a lot of word embeddings available. We have a lot of log data available to us, as you could see, and we have to convert that into vectors that represent meaning. So using word to vec, a popular technique, we can convert each error or each sentence into a low dimensional vector that represents meaning. So what's the advantage of all this? So the first, these are some of the advantages that we found out. It was basically we can analyze data, we can put unstructured data into structured data, we can build up meaning in our unstructured log files. We can map out similar days using clustering on those vectors. So we could say, okay, on Monday there are these kinds of errors, on Tuesday there are these kinds of errors. And then we can also map out the time of errors, what time are the errors most active. And all these are through the clusters. We build up clusters and we could see different patches being made up. And there's a lot more to utilizing word embeddings in this space. And I would like to point out that the log data does not contain the the machine state, but it also contains user actions. Basically, how the dentist uses the machine and how the CAD software takes in the commands. So the next model is the gradient boosting. As you could see, this is a working diagram of gradient boosting trees where they take in model and learn from its residuals and so on. This is an iterative process. And using our 23 column sensor values, what we found out that if we could add in a feature of our embeddings or using the log data that we found out, we had a way to connect word embeddings and gradient boosting. And we built up an end-to-end ML training pipeline where we took in log data, took in sensor data, so basically took in unstructured data and structured data and consolidated it using word embeddings and applied gradient boosting to it to predict what sensor values yield an error or what sensor values do not yield an error. So this is an end-to-end process that we have replicated in this industry, or basically for our case in the dental milling industry. And so what's the real world impact we see? We now have a way to combine all the streaming text data and basically the unstructured data and the tabular data. Now, this is extremely useful to us because there are lots of log data logged every day, and there was no way to make it understandable. Now we have a way to make it understandable using a column as the word embeddings in our gradient boosting model. We could also find out what what feature contributes to the importance of the label. So we could do feature importance to find out what columns are the most important. So this gives us an idea on what to improve and what not to improve. And we see based on our initial experiments that there is a 10x boost in our performance, in our accuracy, and that is a huge boost in this area, given that we are consolidating the text and the sensor data. And the last point, and this would be my closing point, is we effectively show how we could use AI and data science in the computer aided manufacturing industry to identify the 3 Ps. And that is it. Thanks a lot.
Brilliant. Thank you, Kapoor. You made it just before we had to start putting on the music. If anybody has any quick questions, please put it into the YouTube